Hello, and welcome to the New Mexico Bureau of Geology and Mineral Resources GIS Informal Lecture Series. I am your host, Phil Miller, and today's topic is going to be a continuation of last week's topic, georeferencing. And I recognized last week was probably a little problematic, and I sort of anticipated what was going to happen, and sure enough, it went as anticipated. So this week, what we're going to cover is kind of those idealized scenarios when georeferencing so that you can understand the fundamentals of how georeferencing actually works in a good use case scenario. And what I'm going to end up doing ultimately is probably making a georeferencing sub playlist as well and reordering these in the order that they probably should be done in. On top of that, I do think that I'll probably get through most of what I want to cover today, but then I do kind of want to go back and a little bit revisit that first session in order to cover some of the things that I wasn't able to get into. So today is kind of that idealized, perfect scenario. What is georeferencing? And I'm also going to show how the complexities of georeferencing, and it's not complexities, it's the different variations of georeferencing that are available to us as users. So what I'm going to start off by doing is I'm going to go ahead and go in and add a mylar. So I'm going to grab the mylar of a geologic map that represents the Bishop Cap 7.5 minute quadrangle, and I'm going to drag and drop it in. And again, we're going to see all the warnings that we saw last time where we have an unknown coordinate system, and that's because this image has not been georeferenced. So the first thing that we want to talk about in that idealized world is when we look at the image, do we have features that we can georeference to? And a lot of the times when I say features, I don't mean specific features, but do we have targets that we can pinpoint? So the first target I want to talk about on this map is the fact that we have multiple coordinates that we could use. So I've got latitude, longitude. I've also got 10,000 foot ticks in a New Mexico state plane coordinate system, as well as the UTM, the Universal Transverse Mercator coordinates as well. We can use all of these to place this image on those coordinates. And that's the reason why a lot of the times you see maps with the grids and graticules, and not to a lesser extent graticules, but the grids on there so that you can actually relocate this when you printed it out. As a perfect example of an idealized scenario, this base map was built in GIS from the vector data. And when I zoom to our study area, all of that data is represented right here. And I'm going to go ahead and turn off the world imagery clarity so that you can see. That is the data that produced that base map for us. So there's a literal one-to-one relationship with the features, the targets that we see on our map to the targets we see here, and we can physically use them as well as those coordinates. And I'm just going to show the layout really quick so that we understand that's how we got this located the way it did. So if we zoom into this upper right-hand corner, we see a lot of those things able to be georeferenced too. And it can be as nuanced and comical as if there was a coffee ring on the corner of this map when we printed it out. Well, that's a bad example, but let's say we georeferenced a map that had a coffee ring on it. If you then print it out from the GIS and it has that coffee ring stain on there, quite literally, you can use the coffee stain to georeference to the coffee stain. I know that sounds weird, but the reality is we're just trying to locate things at the location that they were. And that arbitrary feature that isn't existing on the globe, if it exists in our database, if it exists in a pre-existing image, we can reuse that same thing to georeference to. Now, the reason why I use that coffee stain example is because for many years we downloaded maps from the USGS, and there was one specific one that the only copy they had a coffee stain on it. So quite literally, the version you got from their website and downloaded had a coffee stain on it. It was already georeferenced. So if you used that as your base map, printed out field copies and went and mapped on it, scanned it in and came back in, you had the coffee stain to use to georeference. I totally recognize that that's silly and absurd, but it works because we're just targeting a location and placing it at the source. We're going from a source location to a target location, and that's fundamentally all that really matters. So I talked about the fact that we can georeference to any of the different grids that we have on here, the different coordinates that we have on here to georeference to. We can also georeference a raster, because again, we're talking about georeferencing a raster. We can georeference the raster to a vector. So I'm going to switch back to the map pane, and we can see that these contours are physical vectors. We can georeference the vector that's printed out now on the raster as cells to the vectors and actually have it start snapping to physical features if we have snapping in our GIS turned on. For example, the intersection of this contour interval with this river, we can actually use the intersection of those two vectors from the rasterized map that has these vectors on there now as cells that are printed out to the physical vectors that they came from, that the cells came from when they were printed. So there isn't much to it. Again, it's a basic process for getting features from one location to another. And then another thing that we can do is use the features on our raster that we're georeferencing to another raster. So let's work through the list. We talked about georeferencing coordinates, georeferencing to coordinates. We're going to show georeferencing to vectors, and then we're going to do a georeference of this to a little trick here to a raster of a satellite image. And then we're going to go ahead and georeference another raster to this raster. And we'll talk about that in a little bit because they're not exactly the same, but you'll see how this all functions. So we'll show the three different types: georeferencing to coordinates, georeferencing to vectors, and georeferencing to rasters in kind of two different varieties. So I have zoomed into a raster that we want to georeferencing. First and foremost, we need to switch to our imagery layer. Once we're on our imagery layer and we've got multiple layers in our table of contents, the key thing that we need to ensure that we do is make sure that we have the raster that we need to georeference must be selected. Because when I click on this georeference, it will be georeferencing the raster that is selected. If I were to add in more than one raster, we would need to make sure that we're on the raster we want to georeference. When we start a georeference session by clicking this button, it will only allow us to georeference that specific raster. And that's a big gotcha and a big thing that we need to focus on. And if I do this by accident the wrong way, we should see that later on if I forget. There's a fair warning. So I've got my Bishop Cap Geologic Map Mylar selected. I can go ahead now and start the georeference. So I click, I have now entered into a georeferencing session, and my dialog box pops up and lets me know which image I'm georeferencing. This is your clue to help you remember what you're georeferencing. And that's a distinct reminder for the nuance that might happen later on. So I usually pick the upper left-hand corner. It's the American in me, top down, bottom to left to right, and how I read. So that's a fundamental thing that I have a nuance of. Now, I can see that I've got an intersection of our coordinate here and here at this location. So I don't need to know what this coordinate is per se right now when I'm georeferencing to a coordinate, because what I want to do is I want to do the best job I can picking the pixel, the individual pixel that represents that specific intersection to the best of my abilities. And when I look at a raster like this, I kind of look at what the darkest line is, and I also try and see if that is the average pixel height of the blur that we see in a raster. So I can pretty much say that this row is probably the center line of that latitude. When I look at the longitude, it's kind of probably somewhere in between here. So if I draw a line between these two, it's probably somewhere between these two or these 4 pixels here. So that's what I'm looking at to hit my from location. I want this to go somewhere. And again, I'm trying to pick where I believe represents the pixel or pixels that represent that coordinate that I'm trying to georeference. So I've kind of identified that. So now we need to go to our add control points to physically start adding control points. So I click my add control points tool and it activates. And again, it reminds you, we're adding our from point, our source to our target. We want this feature right here to go to that coordinate. So what I'm going to do is, again, identify to the best of my ability the intersection of that coordinate, and I believe it's something like that. And I click with my mouse, and I have now added a control point. And now is the time that I want to add that coordinate system, but I can't see it. But I zoomed in so that I could be very precise with where I'm selecting. The more precise you are with picking that first location and your second location more specifically, the more precise you are, the better your georeference will be overall. That is a key lesson and a key take-home message. The precision you georeference with will translate to how well things georeference later. Now, georeferencing to that coordinate is an absolute, right? I can absolutely type in values and pin that location to that point. So the only error I introduce is how well I pick that first point. That's something to keep in mind as well. I am the source of error in georeferencing. So that's something to keep in mind, which is why I zoomed in. Now, to get the coordinates, I need to zoom back out to see what those coordinates are. So I need to get to a location to where I can physically see what those are. Now, I'm ready to go ahead and place my 2 point. What do I want that location to go to my target? And in this case, since we're doing coordinates, what we want to do then is right-click on our mouse to then be able to input our coordinates. And right now we're in X and Y. I would rather see this in DMS so that I can actually do it in degrees, minutes, seconds. So 109, I'm probably supposed to be at 106 for my longitude. So right now we can physically put in that precise location, 106, technically negative 106, 37 minutes and 30 seconds. We are in the Western Hemisphere. That's a good thing to pay attention to. And our latitude then is 32:15:0 in the Northern Hemisphere. So when I do this now, what we expect to see when I click OK is that from pixel to go to my coordinates that I just typed in. And sure enough, I click OK and it zips away. So then again, we talked about this a little bit in that first session. We want to right click and zoom to layer so that then we can find out if this went to the right location. And if we look down at the bottom right here, this is the coordinates of my map in decimal degrees, yes. But if I hover over that, it looks like we managed to put that in the correct location, 106.625 and 32.25. So we're right where we need to be. And I can zoom out then and see that we are basically in the upper left-hand corner of the extent, the northwest corner of the extent of our map. So that point went in perfectly well. I'm going to zoom back into my layer so that we can go ahead and continue. Now, I don't know how much this matters, but in my experience, when I work with things like this, it seems like this may be an observation bias, that when I georeference opposite corners and I try to get the furthest extent of my reference image that I'm trying to georeference, the better off my georeference is. You want to get as far out from the center as possible and get some of those locked in. I also do this kind of in and I'm going to call it the star pattern. And I use that as a reference, like when you change the tire on your car and you want to bolt the lugs, the rim back up using the lugs. You kind of tighten in a star pattern so that it settles in smoothly and does a good job of centering the wheel on the hub. I don't know how much that matters, but to me, I think I see a better georeference. So what I tend to do is I go to the opposite corner then of the image I'm referencing. I've got nothing down here that I can georeference to. It would absolutely be better if I had something down here I could georeference to, because the image includes this size, right? It's part of that image. So if we start using third order polynomial or some of the other transformations, we'll see warp over here because we can't put control points there. That's the reason why I think this kind of matters. So one of the other discussion points too is you could go ahead and crop this out before you start georeferencing to limit the pixels, the size of the image that you have to georeference. But let's go ahead and go through the process. I'm going to go ahead and add in the 16 control points to the best of my abilities. So there's going to be a bit of lag here, and you in YouTube land won't see it because I'm going to cut that out. But this will take a little bit of time to get these 16 control points in so that I can use the spline transformation. We'll talk about the transformations along the way. But I'm going to go to that opposite corner so that I'm stretching the image as evenly as I can to settle it into place to the best of my abilities. So again, the process is click from where I'm georeferencing, and then when we're doing coordinates, right click, show DMS, and I want this to go to -106, well, 106, 30, 0 in the Western Hemisphere, and 32, 7, 30 in the Northern Hemisphere. I click OK, and we'll see this image stretch out. So now the image has stretched out. It's going to take a little bit to draw to resolve, but once it resolves, you'll kind of see that it looks kind of funny. And as we zoom out, we can see that we have now stretched that image out to exist where this map now exists. So I've got 2 control points. I'm going to go ahead and continue adding the rest of them. You in YouTube land will get the joy of skipping all the rest of this. All of you watching with me live, I'm sorry, this is going to be boring. And you're going to see that georeferencing isn't hard. It's tedious more than anything. And if I'm not mistaken, there is a way to make this do DMS every time. I did not set it up that way, and I'm now wishing I had. And this one's going to be a little tricky because I have to infer where that intersection of my latitude and longitude is, because a label is obscuring that. And again, this is where now user error will introduce more error than anyone else will. Okay, so I have georeferenced the 4 corners now and have basically pinned down the image, and we can start talking about transformations, because Similarity requires 3 control points. First order polynomial requires first points. But in order to get to second order polynomial, I need to go ahead and add 6 control points. And what we're ultimately going to end on is a spline. And ultimately, we'll have 16 control points. But you can see what the minimum requirements are for these. So we can do adjust, we can do projective, and get different transformations happening, and probably with as many control points as we have, and as well locked in as these locations are, as easy as these targets are to identify is probably a better way of saying it, the transformations will likely do very little from one another because we're picking so precisely. And it's only when we start adding control points in the second order and third order polynomial that we'll start to see warp. And warp will also occur if we don't have good control over where we're locating things. That's where the warp starts to get a little excessive. So I'm going to go ahead and continue adding in control points. I did that. Let's do this one now. We click, right click. I am at 106.37, 30, 32, 12, 30. Okay, so now I have placed my 16 control points. And what we're seeing in this graphic right here is my from location and where it's going to. So this is where I clicked. This is where it wants to place it. So we can see that there's a line connecting those. That is the amount of stretch that is occurring in that with this specific transformation. So we can see that this one is actually closer and tighter than this one is. And if we open our control table, we can take a look at the residuals to see which ones are the most problematic as well. So if I click on sort by residuals, we can see that some of them have some issues and are pretty far off, and some of them get a little bit better as we go. We also have the number with which I referenced them in. So somewhere in the middle or towards the end, we had a little bit better control. Again, as we stretched the image, it was a whole lot better with getting those in there. The middle of the road and some of the later ones are middle of the road. And then some of the intermediate ones were really the more problematic ones. Now, if these were really bad and we knew they were bad, you could go ahead and turn them off so that they didn't influence the georeference. But I did want to go ahead and talk about this pane and also show that we can adjust the transformations here or here. This is the transformation field. So currently we are in projective. I'm going to go back to first order polynomial, which is where we started, to show you what the residuals become for that. So not much change there. Some of these numbers got a little bit larger, but not by much. And then if we look at the image and zoom to the image as a whole, you can see that there's not warp occurring. We don't see this hard right line doing weird zigzaggy things or stretching out of ordinary. That means we got pretty good control over what we georeferenced. So that's first order polynomial. We can go to second order polynomial now because we have enough points. And now we start to see that warp occur. That's what I'm talking about. And it's likely because we don't have anything down here to control the image location. We have no way of rectifying this in any way because we don't have these texts on our layout as a feature. So we're at second order of polynomial. I'm going to go ahead and go to third order polynomial. And we see sort of a different warp. And if we look at the residuals between those two, and I'll sort again so that we can see that there's not much trend that differed, but our worst ones actually got a little bit better. Let's go ahead back to second order so we can again sort those. And again, not bad, but they got a little worse when we went down a level of transformation. And then if we go ahead and go to adjust, we'll start to see these really pinned down pretty well. And then as we go to projective, that's where we were when we first started. And then I'm going to go ahead and go to spline. So spline, we can see that we dropped that residual to absolutely nothing. And it's a byproduct of the pull. Did anyone see what I did wrong when I was georeferencing? Can anyone pinpoint what is wrong with my georeferencing when I did spline? There's 2 points that should be screaming bloody murder to you right now. I georeferenced to my map edge where the coordinate was, not where the tick is. Weird. Why am I getting warp? Because of these 2 control points. So let's go ahead and show the process now for showing the controls, taking a look at those, and using the control table to go, oops, I goofed up. Let me get those 2 points corrected. So I'm going to go ahead and go to my first order or similarity. It doesn't really matter in the grand scheme of things. And the cool part is when we sort with these, if I select the control point, the worst residuals, oddly enough, are those 2 control points. So very easily, when our worst control points are our problems, if we sort by that residual, we can find out which one are the worst offenders. I can now delete that control point. I can also turn them off to see what it would look like without those control points affecting the stretch. And sure enough, getting rid of them, look, that warp went away. Oh, I now have proof that these 2 control points are bad. Well, I might as well go ahead and remove them. Oops. Oh, I can't multi-select. Bummer. I'm going to go ahead and delete them now from that control, and now I can add them in the correct location. So I'm going to go ahead and zoom back in. And again, I'm sorry this is boring, but I definitely wanted you to see bad control points and how they affect your georeference. So if we come in here, I need to turn. So now that I've got that, if we go back to spline, look, no warp. So that's another clue to let you know if your georeferencing is working or not, is if you're starting to see warp, you can identify issues. The question that probably everyone is asking right now is, which transformation is best? That's a tricky question. It depends on what you're georeferencing and what you're doing. And it's a mathematical operation that is happening in the background to get these things to fit. I am not good enough a mathematician to explain this, but the way I typically talk about this is that rubber sheet effect. And each of these has a bit of tensor math associated with them. And the pull and the distortion is a byproduct of the math that these different mathematical operations are doing to rubber sheet that image. And I used to give an analogy when I was teaching the class that, if you've got a cat right here laying on your bed sheet and you're trying to make the bed and you're pulling on it, the cat anchors that corner down as you're pulling from this corner. These 2 corners over here kind of squeeze in because the cat is weighing down one corner, you're pulling down the other corner. If you had 16 cats evenly distributed and placed them all around equally, they'd all pull an equal amount if they were all the same weight, et cetera, et cetera. With spline, one of the reasons why I use spline on this one, and this is one of the warnings that I have to give, with spline specifically, one of the assumptions that is made with spline is that your points are well distributed evenly. That's the key with spline. Now, there's other times where if you add enough control points, you can overcome that, but you have to end up placing a whole bunch of points in certain areas so you can get equal weight. And there's a weight associated with the proximity of points to one another. If you've got clusters of points, that cluster will have more weight than a single point, and that's something to keep in mind. If you start getting clusters, you'll kind of want to try and distribute the control points outside of that area. So does everyone now see how I've got my georeference showing up? Does everyone understand how this process works? And again, I recognize that this is the absolute most ideal scenario. We have physical coordinates to reference to, and we've got the locations of those coordinates identified on our raster as well. So with that, are there any questions that anyone has? Okay, so now what we're going to do is I'm going to go ahead and georeference some of the features we see on our raster to the features we have that are vectors so that we can see the process of rectifying to the raster to vectors. So you can pick any feature that is readily identifiable. Things that are readily identifiable tend to be sharp jumps in contours or something like that. So this sharp angle right here that we see propagated through would be a good thing that we could identify. Another thing that's easy to identify is the intersection of this creek bed with this contour. That's another thing that we could do. And right now with my layer order, my bishop cap mylar is on top of my vectors. And if I turn that layer off, we can see those physical vectors underneath. This is one of the things that we can now do to this image is come to the raster layer settings and do a multiply blending mode so that we can see both simultaneously. Commonly, this is the area where people get in trouble because they forget what they are georeferencing and what they are georeferencing to. And this is where you start accidentally doing them backwards. You click what you are referencing to by accident because for whatever reason, our brains are like, look at this sharp, crisp line. I can identify this. We click this and then we click the raster. That's the opposite direction. So remember, it's what we're georeferencing to what we want to georeference to. That's the gotcha. So in this case, it's actually easier to go ahead and turn things off and on as well to help us identify them. So I can go ahead and turn off that topo layer so that I could identify my tightest radius that represents that point. I can then click on my raster, turn on my topo layer, and then I can rectify to the vertices within that vector file. So whether it be a midpoint, an end, an intersection, and a vertice, a specific vertice. So I'm going to go ahead and click at this midpoint, and it'll see that image just pull over just a slight bit. So that's how we can do this. And then I'm going to go ahead and pick a location somewhere else. Again, we're trying to spread out our control points as best as possible to try and not get clusters. So I'm now going to pick the intersection of a couple of features. So I'm going to turn off my topo so that we can see the intersection. I'm not going to do that one because that one's problematic. I'm going to do this right here. So this creek intersects, this ephemeral stream intersects this contour interval right here. So what I'm going to go ahead and do again is we click what we're georeferencing, and I'm going to do the best to pick that intersection, turn on my other layer, and then I'm going to go ahead and try and click the intersection of those two to the best of my ability. I click and we'll see that image slightly pull down. So that's rectifying a raster to additional vectors. The other factor that we have on here is we absolutely have roads on this raster. Roads show up in orthophotos. So we can also georeference to satellite images where we can identify road features. And intersections of roads are usually the best thing in the world to do that too. So I'm going to go ahead and turn off the vector files now so that we're only seeing the image we're georeferencing and the world imagery raster that we're georeferencing to. So raster to raster. And my blending mode is actually getting in my way a little bit. So I'm going to go ahead and go back to normal, but then make it like 50% transparent or something like that. Nope, too much. Okay, so we don't see the nuance of the curvature of this road like we see in the ortho photo, but we can definitely identify the intersection. And we have another problem. This one is kind of getting in our way. So maybe this isn't the best one to identify. Let's go to another intersection or another readily identifiable feature that allows us to georeference this. So we can see this little loop here. The question is, can we see it in our orthophoto? And that's the take home of this lesson in its entirety. If you can identify two coincident features in your raster and whatever else you want to rectify to, you can use them to reference each other together. So we have to ask the question, can I identify that little loop there? Well, kind of. It's this right here, but is that readily identifiable? Would that be a good feature to use? The take home in this case is if you need a control point in this location and that's the best you got, it's the best you got. The human error factor sometimes has to be an acceptable amount of risk. We have to acknowledge a certain amount of responsibility with rectifying. But in this case, I don't have to pick that one. There's roads out here that I can easily identify and pick. So highway off-ramps are a great example because they usually show up so well. Oh, but I'm off the map. Bummer. So we need some other road feature or some other identifiable feature that we can make out. The problem with New Mexico is lakes are not always lakes. So let's go ahead now and go back to a road that we can georeference. So again, we have a similar issue to the one that had the lettering over it. Curvature isn't quite as identifiable, but we've got multiple features in here that are triangulated that'll help us identify something to georeference to. And they're not perfect. So this is the common problem with georeferencing two features that aren't perfectly ubiquitous. But we do have this one. This will probably suit us to the best of our abilities. So we want to recognize that there is a slight curvature here. And we want to recognize that we're trying to do this to the best of our abilities. So in circumstances like this, I would actually probably pick right here because the curvature doesn't match. And I'm going to try and eyeball where this intersection and this intersection turn to create this common reference point here. Turn our features back on, and we can see how we did with eyeballing it. And the lesson there is at times, we can only do the best we can for what we have. If this, again, this is the lesson for if this is what we have, this is the best we can do. Sometimes we have to accept that that is literally the best we can do. So that was the image to coordinates. That was the image to vectors, and that was the image to a raster as well. Now, let's go raster to raster comparison. And what I have is, sorry, give me a second. I need to now close my georeferencing session. It is asking me that I have unsaved edits. Those last couple examples that I did, I just wanted to show you georeferencing to vectors, georeferencing to the raster. Yes, I want to continue. I don't plan on saving those. Again, those were for example purposes because I want to move on to another example, which is why I saved this image that we can work from. So this is that rectified image that we used the coordinates to rectify to. What I have is another image that is a subset of this image right here. And the author went ahead and colored in some features. And this is a real world scenario that often is a necessary evil that we need to deal with. So I'm going to turn off all of my vector layers so that I don't have them to deal with. And I'm going to rectify a raster to a raster that has common features. And this is the lesson for this one. So I'm going to go ahead and drag and drop this in. I'm going to zoom to that layer, and we can see that there is a commonality between these, and I can use the geology, and I can use some of the vector field stuff that we have in this image. And it's always best, again, to find features at the edges of our map to georeference to. So I have the author's contacts that they drew in. I've also got the labels that they drew in as well as features I can use. And I've also got a road intersection that I can use. I'm going to go right off the bat and show you again that coffee stain example. So what we need to make sure is that this QCP is the same QCP. So what I'm going to do is zoom back to my layer, come over to my area of reference, and if I zoom into roughly the same area, that sure looks like the same QCP. That looks like the same 35. That looks like the same 10,000 foot tick mark. Yeah. So there's features here that we can use that have common reference between the two images to rectify them to each other. So I'm going to go ahead, zoom back to my layer. I'm going to use the Q for the cute example. I need to start a georeferencing session because I stopped my other georeferencing session. So again, we come to imagery, georeference. We have now started a georeferencing session. I want to add a control point. I'm going to use the intersection of the leg of the Q and the circle of the Q. There's a name for that Q leg, and I can't remember what it is off the top of my head. And then I'm going to go ahead and zoom to my raster. Oops. I'm going to go find that QCP, and I'm going to georeference to the intersection of that. Sure enough, I now have features. I can rectify this part of this image to the raster. But again, am I spreading out my georeferencing then? No, I'm not. I strongly recommend that we go to the opposite corner. And if you don't, and you end up georeferencing something in a line where where it doesn't have any triangulation, you will see an error. Well, at least we saw an error in ArcMap that was collinear georeferencing. I don't know if that pops up in ArcPro because I don't georeference that way. If you georeference three coordinates, three things in a complete straight line, no matter its orientation, we used to get an error called collinear georeferencing, and it is a source of user inputted error, and it creates a problem. That's why I strongly recommend we go corner to corner. So again, I'm going to cheat and use the QCP. Make sure I'm on the right image. I am on the right image. Click what I'm georeferencing. Zoom out to where I can see my QCP over here. Stretch that image out to the best of my ability. And now if I do a little bit of image work and make this be a multiply, you can now see the comparison of the georeference. Pretty spot on, isn't it? So that's georeferencing a raster to a raster. And again, you'd want to go around and do more control points than this because there's likely areas that will be offset somewhat. They probably won't line up perfectly. Yeah, and we're seeing it right here. So you can now see the difference between the two. This is why we need to go ahead and add in more control points. And this is also the point to be very careful about what you're clicking on. Which one is which? What am I georeferencing? I should probably make sure I turn off the image that I'm georeferencing to so that I don't get confused, because this would create the reverse scenario that I mentioned earlier. So I'm going to add one more control point. I'm going to click here. I'm going to turn my other layer back on, turn my referencing layer off, click what I'm referencing to, turn my layer back on, and we should see an alignment of those features again. The more control points you add, the better off you are. So let's pretend that I've added a whole bunch of control points and finish this process out in its entirety. Before you are done georeferencing, you will want to rectify this image to a location. You will want to save it with a coordinate system in there. So I need to go back to my georeferencing pane and click Save as New Raster. This creates a new raster dataset with the georeferencing transformation applied and a coordinate system assigned to that raster. So I'm going to click Save as New. I'm going to name this Bishop Cap IPBMRSF in an appropriate folder. Your folder may vary based off of your organization or program. What we do in my group is when I'm rectifying an image, I go ahead and add RECT to the end of the image to explicitly specify that this is the rectified version so that we know the difference between them when it adds it to ArcMap in the end. I tend to do TIFFs, make sure the coordinate system is the coordinate system we want. And then compression type, I usually do a lossless compression. Again, your mileage may vary based off of your need. I click export. It will now go ahead, write that image with the transformation applied. It will write that image with the coordinate reference system, and it will add it to our map as the rectified image. So again, these are the most ideal case scenario for georeferencing an image. At this point, also I should mention, don't forget to close out your georeferencing session so that you are done georeferencing and you can keep going back to doing whatever it is you want to do. Okay, so that again is the most ideal case scenario for georeferencing, rectifying an image, getting it located, saving it in its new location, and it adds it to the map for us. Awesome, great. I want to thank you all for participating in the GIS Informal Lecture Series. I want to thank the GIS Services Program and the GIS Services team for being the awesome team that allows me to do this every week and get these messages out to you. Again, if you have topics you want to talk about, we are happy to hear those questions and go ahead and get you coordinated with getting rectified and georeferenced. We appreciate your time, and we will see you in the next session. See ya.